In this question, it says a detector is placed near a radioactive isotope and records a count rate of 700 counts per minute. So let's take note of a detector. So a detector is what is measuring the count rate. And anytime you hear that the detector is measuring something, note that in most cases it involves the background radiation or background count rate, unless the question specifies tells you to ignore. So in this case, it says it has a half-life of 8 minutes. The average background count rate is 60 count per minute. So before you understand this question, you must first of all understand this relation. So I will call it the measured count rate, which is MC. That is what the detector is measuring, should be equal to the sample's count rate plus the background count rate. Very important. And also, let's take note of our radioactive equations. So the first one, I will say A is equal to, where A is the count rate at a specific time, or count rate after a specific amount of time, should be equal to your initial count rate, so A naught. So initial count rate, that is when time is 0, over 2 raised to the power n, where n is the number of half-lives. And then another relation that we can also use, that's the formula for half-life. So half-life, which is T half, is equal to the time, the given time, which is T, over the number of half-lives. So let's keep note of this equation. Remember, this equation that I've given here, this equation and this equation is only used on the sample count rate. It's only used on the sample count rate. Let's take note of that. All right. So from the question, we have been given the measured count rate and we have the background count rate. So it means to get the samples count rate, so the samples count rate, it must be 700 minus 60. That will give us 640. That will give us 640. All right, good. Now the question says, what is the count rate measured by the detector after 16 minutes? So obviously we are going to use this formula to do such calculation. We already know our A naught, so we know our A naught now is the 640 that I just calculated. So that's what I'm going to, let's take note of that. But first of all, we need to find our n, and we can use this half-life equation to find our n. We know that the half-life, T half, so our n will be equal to the time we are talking about over the half-life. So our n is equal to 16 divided by 8. So our number of half-lives is 2. So we have that here. So now that we know the number of half-lives to be 2, let's now find the count rate after the 16 minutes that we are talking about. So in that case, my A, which is what I'm looking for, is equal to the sample's initial count rate, which is 640, over 2 raised to the power the number of half-lives, which is 2. If I compute this, I will get 160. So the 160 will be the sample's count rate after the 16 minutes. But the question is asking for the count rate measured by the detector. So which means that what we are looking for is the measured count rate. So which means to get the measured count rate, we should add the background count rate to the sample's count rate. So to get my measured, it must be equal to 160 plus 60, where 60 is the background count rate, which will give me 220. So my answer is D. So it's very important, you know when to subtract, when to use the sample country rate, when to use the measured country rate. It's very, 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 very important.